All right, so here's a few news articles. Jeff Bezos is going to step down from being the CEO of Amazon. And so somebody else will take over, and that may have some effect on Amazon. We will see what happens. Not clear what it means just yet. And what is this garbage? Okay, Elon Musk wants to stick chips inside people's brains, and he has a version of it already working on monkeys, and he wants to move into human trials soon for people who are paralyzed. And after that, he would like to move into healthy humans who just want to augment their brain with a computer in their head. So that may be exciting, although I think that third thing will be quite a ways out. Yes, that's the idea. We will become cyborgs. The head of Google wanted to do the same thing a while ago. A lot of people wanted to do it. It's a science fiction staple. Augmenting your brain by mixing you with a computer. If it worked, it would be nice. Amazon news only matters if Jeff Bezos donate money. Yes, he probably will start donating money like Bill Gates. He said philanthropy will be a big thing, and focusing on the Washington Post will be a big thing. So he'll still be doing something, but somebody else will be in charge of Amazon, and that may have consequences that I can't guess. Focus on Blue Origin. Oh, Blue Origin, that's his space thing, right? That's what somebody said. He's got a space thing, and so does Elon Musk. So they both really want to move into space. You know, that's what you get, I guess, when you're that rich. You start thinking about big things. And Google is going to start writing part of Apache in Rust. Rust is the language invented by Mozilla, which is specially designed to prevent memory corruption bugs. In fact, I'll probably add a couple of Rust projects to the Python workshop that's coming up because I wrote some, and you can see why Rust is safer than C there. Anyway, and speaking of that, we've got, the next event is CactusCon this weekend, Friday and Saturday. I recommend going. You can, yes, Rust is the whole point of Rust is to be far more secure. Rust is designed to greatly reduce memory corruption vulnerabilities like buffer overflows. And it certainly does that. The problem is it's much slower in its current implementations. That's right. You carefully define exactly how big every variable is, and it does not allow you to overrun variables, not integer overflows, not string buffer overflows. You know, it carefully prevents all those things. But at the moment, it's extremely inefficient and slow. So if you wrote the whole operating system in Rust, it would be very slow right now, and they're working on developing it. Anyway, so we'll have a Python workshop there. You can come to that if you like, or you can go to anything else. It's worth extra credit if you go to CactusCon. Anyway, all right, so I think we're ready to get going here, and the lecture is probably not too long today. You know, and my demonstrations may not work because I was unable to get Genymotion to start for some reason, even after reinstalling it. So I have to diagnose a problem with the network adapter. When I get it fixed, I will add notes to guide other people that may have the same problem. I'm thinking perhaps reinstalling VirtualBox will help. Anyway, so we're here in the schedule, down to the second part of analyzing Android applications. And I reckon that the slides will work anyway, even if I won't be able to demonstrate it live tonight. So it should be 6B, which should be here. All right. And let me move the share over to there. Good. Okay, looks like things are working as I thought. I've set my graphics to mirroring, and that seems to make Zoom work better. All right, just an empty square. It filled up now, right? Because I see it looked good for me. Do you guys see the slide? Yeah, people see the slide. See, I've got my own monitor showing what you're showing, so that's helping, I think. Anyway, so we're going to do the second part, which is the Android security model here. All right, okay. And all right, so then the security model, the idea here is that no app should be able to access another app's data. And Android has to know who created an app, so it knows who's allowed to update that app, and also so it knows whether it's an official Google app, because the Google apps have special privileges. And they do it with code signing, which we talked about. This is doing public key cryptography, the same old RSA-based signature that we've been using for decades on the internet. But you have a public key and a private key, and the private key the app developer has, and it is not distributed with the app, of course. So you generate the key with key tool, you sign the app with jar signer. We'll be doing this in the projects. And then it creates a signature, which goes in the META-INF directory. And the result is, for example, if you download the Bank of America app, which we'll do in the project, you can take it apart with APK tool. And when you do, it removes all the, unpacks this zip file, which is what APK tool files are, and then it unpacks all the files inside there, backsmailing to turn this stuff back into Smalley code, which is almost like Java, readable. And it also unpacks other things like the manifest file and the signature. So it puts it all in these various folders. And so if you go look in the META-INF folder, you will see the certificate, cert.rsa. And if you look at cert.rsa, you can see it's just an ordinary digital certificate with a serial number and a validity date range. Notice, by the way, the validity of this one is from 2008 to 2035, which is like 17 years, which is normal. They recommend putting these dates 25 years in the future, because if this certificate ever expires, you will not be able to update the app anymore, because the only way to update an app is to have another version of it signed with the same signature. If the signature is not valid, that won't work. All right, and this, and by the way, it uses a really old RSA algorithm, notice, which is considered a security risk, MD5 with RSA. MD5 is a really old hash function, which was actually never approved for any purpose by the government. And so, but yet it turns out these certificates are more secure than you might imagine they are. But of course, it is using a very old signature algorithm, and it's using it for 25 years, which is another clue, because if you pay attention to certificate security on the internet, it tends to update every couple of years. So even if you use the latest best signature algorithm, it probably would no longer be considered secure in 25 years. So anyway, you can open up the app with OpenSSL and see what's in there, and you'll find in there the public key. This is the point. And by the way, notice it's only a 1024-bit public key, which is no longer recommended. So this is a really old-fashioned signature, not at all as secure as the kind that your browser would require to connect to a modern web page. All right, and there's the algorithm MD5 with RSA. There's the certificate. All right. So as I said, you could be surprised if you've been learning about cryptography in your Security Plus or anything. MD5 has been considered unsafe for a long time. And all the way back in 2008 at DEF CON, they were able to make fake root certificates for certificates created with MD5 hash values. So in principle, a certificate like this can be forged, although it is not easy. And the point is, it's much harder. Now, the reason why MD5 is not considered safe is because you can generate two files with the same MD5, and it doesn't take forever. That's not too hard to do. So an MD5 signature does not mean a file has not been modified. But that's not the same thing as taking something with an MD5 and creating another thing with that same MD5. The way you do it is you start from a file, and then you find a way to add a few extra blocks to it. In ways that end up to be the same thing. So anyway, that's why this is more secure than you might think it is. But anyway, since the certificate is not validated anywhere, it does not go to a real certificate authority, then it's just self-signed. So the only point of this thing is to make it so that they can tell if two apps are from the same developer. That's the only point of it. And in practice, it seems to be good enough for that purpose. But it is not at all the kind of certificate validation you see on web pages. So that's a thing to know. All right, and there turned out there have been quite a few signature validation flaws in Android apps, although they have not been because of the lack of the sufficient cryptography. And here's some of the famous ones. The master key vulnerability found that if two files have the same file name, then only the first file's hash is checked. So the second file is actually deployed to the device. So you can make an app with a malicious file added that will still match the old signature, and the wrong file will get added to the device. This kind of flaw happens a lot. Hear about this a lot in security. All right, another one was the extra field length. There is a length field in the certificate, but it's a 16-bit value, and Java treats it as a signed integer. So all you have to do is make it bigger than 32,000, and it will be interpreted as a negative number. And that will allow you to inject altered files that will pass the verification. Now, this is a very common problem. And like we're talking a lot in the web app security class, this is when you have different systems that connect to each other. One app treats it as an unsigned integer, the next app treats it as a signed integer, and that can lead to this kind of flaw. Then there was the name field length. The length of the name was not checked, so you could add code injection in the file name. So, this happened a lot. And by the way, the same thing happened to Windows executables. I remember about 8 years ago, I went to a conference like B-Sides or something. There was something when they were talking about injecting code into signed Microsoft applications. And I said, how can you change a signed application? Well, PE files have several sections, and the signature only applies to some of the sections. You can just change the other sections, and it doesn't pick it up. And I'm like, that's ridiculous, but that tends to be what happens. Silly mistakes like that are what leads to most security problems. All right, and then there's permissions. Now, when you install an app like Coinbase, it will pop up this box when you install it saying it has access to your identity, contacts, camera, Wi-Fi, and so on, and then you accept. And so this is it warning you about the things that app will be able to do. And those permissions shown at install time, those things, in fact, are not very secure at all. There are a bunch of vulnerabilities that let you add permissions to your app that the user did not authorize. Also, those permissions go in the Android manifest. You'll see them here in XML file, and here it has the things it can do: access course location, wake, lock, read phone state, access network state, and so on. Those are all the permissions that this app has. Now, however, one thing you can do is you can define a new permission, like, for example, the Skype app. When you installed Skype, Skype lets you make video calls to someone with a different technology than the ordinary phone calls you might make. So they called that a Skype call, and they added new intents, which are signals sent from app to app inside the phone just for Skype. So they define a new permission here, a Skype object with a permission level. So you define a new permission called C2D message. All right, so since you defined a new permission, you determine what are the rules of who should be allowed to access this permission. There'll be a new permission appearing when you install a new app. This app needs access to your Skype calls, for example. So they made it limited by signature. This word here has various valid values. One is normal, which means it'll just pop up in the box. Other apps can ask for their permission and the user can approve it. Then there's dangerous, which means if an app asks for that permission, a box will pop up warning the user that you should be careful because this is something dangerous. A signature is the one you saw here, which means that nothing will be allowed to even ask for that permission or use that permission unless it has the same signature as the original app. And that's what Skype did. So that means Skype has defined a new thing called a Skype call, and it's defined a new permission, access to the Skype call. But the only apps that will ever be able to use this are other apps from Skype, signed with Skype signature. So that is probably a good idea if you're not intending to add a new feature to the phone to be used by many other apps, but you're just intending to make perhaps a suite of related apps from the same company that are going to use that new permission. Then there's signature or system, which would let apps either signed by the same thing or system apps that come from Google would be allowed to access it. So those are examples. Oh, I should put an F there. All right. And then there's development, which is another one not used that commonly. All right. So signature protection is recommended if you don't really need to share a functionality with other apps, which, by the way, is a pretty unsanitary, dangerous thing to do because those other apps might send unexpected input to that field and have buffer overflows or code injection or something. So, if you don't really need to add a new global feature to the phone, you probably shouldn't. And so malicious apps, if you want to install a malicious app on your phone, there's a ton of malware in the Google Play Store. Remember, the very first phone I got a Google phone right away. I went to the store and I downloaded the #1 top rated app, which was like just background smileys or something. And it was all full of ads. And I said, great, malware right in the store. This is awesome. So a lot of malware in the store. And so if you want to have a malicious app that has access to things you shouldn't have, you can just ask the user, because in practice, as many, many studies have shown, whenever you pop up a box like this, users just click OK and go ahead. They don't really read it. They don't pay any attention. 99% of users will just click on anything just to get it out of the way and get to the app. So that's one way to go, probably good enough. Or you can use a kernel exploit, if you can find a weakness in the operating system or exploit a known one, and then you can get root, and then you can just give yourself privileges that the user did not authorize. And there are other vulnerabilities that let you gain permissions. All right, so applications run in what's called an application sandbox, which sounds pretty good. And you might imagine it means that every app is running in a separate virtual machine, but it doesn't mean that at all. That's what Cubes does, and that is very expensive in hardware. It's not what it does at all. All it does is it runs each app as its own user. So you see, I got Coinbase here and I got Schwab on my phone, and they're owned by different users, which we talked about last month. This one is user 129, this is user 145. So there's a whole bunch of different user accounts on the phone. And notice the Schwab app is world executable, which XXX here, which means anybody else can launch the Schwab app. Now, I don't know quite what they're thinking of, but I suspect they're thinking of something like clicking a link on a web page and it opening the Schwab app or something. Coinbase, however, is not it's only executable by the owner, which I think means you can only open that app by deliberately launching that app and not by some other app launching it. User 145 could launch Schwab. Well, yes, but not only user 145 could launch Schwab. That's exactly what it means. This X here, or this is the owner, this is the same group, and this is anyone. And I don't know if these user accounts are all in the same group or not, but these two X's here, 3 X's mean anybody can launch it. So you're creating an executable that anybody on the phone can use. And that's apparently what Schwab did. Now, I don't know if they did that for a good reason or if they're just being sloppy. But it is the case that there's some executable in there that everybody can use. All right, so it's not a separate machine for each app. All it is the separation between users. So is Schwab a vulnerable app? I believe we'll find it's vulnerable to code modification. And I think some Schwab apps actually broke SSL a while ago, but as far as I know, they patched that a few years ago. So I haven't tested it in a few years, but the last I know, it was about as good as any of them, which means vulnerable to code modification, but not vulnerable to the other ones in the top 10 that I can test for. So it's about as good as an average financial app, which is not that good. And this, by the way, gets us into the security model of companies. Many companies just don't understand security very well. So all they do is they do whatever the other companies are doing. And then their lawyers tell them that'll probably hold up in court. If you say, we met industry norms for our industry, most people will say that at least excuses you from gross negligence. You might want to try to do better than that, but most companies don't bother doing better than that. They just imitate what the people around them are doing. Especially financial companies, they do that a lot. Like almost when I first started teaching internet classes, internet usage, and years ago, I tried demonstrating HTTPS. I just opened a bank and it was not an HTTPS page. And none of them were. This was about 15 years ago. None of the banks used HTTPS pages. They all used HTTP pages, and they would have an HTTPS button to log in, which is a terrible practice. And they all had exactly the same sentence on there that said why this is secure. And when you clicked it, it went to a page written by a lawyer that was just full of lies that said this is just fine because it'll be encrypted. And it was absolutely not fine. I even contacted some of their tech support, including tech support from the bank I had, saying, guys, this is wrong. I'm horrified. And I was in class. I said, here, I'm going to show you a secure page. We'll look at my bank. And it wasn't secure. And then all the students started calling out their banks. And I went to them, none of them were secure. I said, hey, this is not right. None of these pages are secure. Anyway, then I think a law changed in Canada and a law changed here, so they felt like they had legal liability, and now banks use secure pages. And now that Google moved everything to secure pages, almost everybody's moving everything to secure pages. And over the last year, most browsers will warn you if a page is insecure, which is a good idea. Anyway, so the next issue you might think about is file system encryption. If somebody steals your phone and it's and they're able to get past your PIN, because I know a lot of people don't even put a PIN on their phone. But anyway, then can they see all your stuff? Well, they can get past your PIN. They can, of course, see everything. But what if they can't? Now, you'd like to have full disk encryption. This is what you have on a laptop if you have, say, BitLocker. Then nobody can read anything off the hard drive. Even if they physically take the hard drive out and mount it in another machine and copy every bit off it, it's all scrambled. And iPhones are very encrypted with layers of encryption and keys to where it is really hard to get anything off an iPhone, to the extent that until for years, it was the case that you could not get anything off a stolen iPhone at all. And then the check rain exploit came out, and now you can read the system files, but you still can't read any personal data on somebody else's iPhone with any attack I know of. Although there are law enforcement devices that are used that sometimes get in. But anyway, so Android phones, you might wonder if they are that safe. And the answer is they are very emphatically not that safe. Now, full disk encryption is what you need for this. This is something Microsoft learned more than 10 years ago when Vista came out. Microsoft Windows had encryption of files on the disk for decades. You could right-click on a file and encrypt it. You could right-click on a folder and encrypt it. And then everything in that folder was encrypted. But what they found out is if you encrypt your home folder, which is the folder that includes your desktop and your documents and your pictures and everything, when you're using things in applications like browsers and Microsoft Word, the operating system makes extra copies of that data and puts it in other places, like the hibernation file and temporary files here and there. So it's not enough to encrypt your home folder and put in like Word documents, and then when your laptop gets stolen, you go to court and say it was encrypted, nobody saw those documents. You have to encrypt the whole system partition, really the whole hard disk in practice. So that's where they got this idea of full disk encryption. The whole point is, if you're going to lose that device on an airplane and that had company data, you have to be able to go to your business partners and to court when you get sued for losing that data and everything. You have to be able to say, we took measures so that even if a malicious person got that stolen laptop, they couldn't get the data off it. And especially for phones, you need that because people lose phones all the time. So you really would like to have full disk encryption, and that's what iPhones have. And they've had it since iOS version 3, which is, nobody's using anything older than that anymore, hardly. So if you lose your iPhone, nobody's getting the data off that thing at all. But Android's not that much. Now, Android has had full disk encryption available as an option, but it's not on by default, not until version 5. And the lower end Android, the cheaper Android phones don't turn it on. The point is it drains the battery. And they don't like that. Now, it uses the algorithm that it should be using, AES, the official government encryption system. So there's nothing wrong with the encryption system. But anyway, the problem is many people have very old Android phones. Here's the latest version, Android 10.9.8. This is from 2020, 10.9.8. So it looks like half the people are more than 2 versions back. And a lot of people are still using all the way back KitKat. 4.4 is the green bar. And there's some people still using KitKat. So the problem with Android phones is they don't automatically update, not even security updates. And so a lot of people are using really old versions, and there are known attacks to get in these versions. I mean, there's nothing you can do worse for your security than using an old unpatched system. And that's what most Android people are using. So a lot of these don't have encryption turned on. And also, even the ones with later versions of the operating system from cheaper phone manufacturers might well have it turned off. So there was an estimate in 2017 that only 17% of the phones were encrypted. And I don't know now how many are encrypted, but probably a lot of Android phones do not have the data encrypted. So that if you lose them, somebody can read all the stored data on the phone, which is why I've given a bunch of DEF CON talks and everything, like I did in this class earlier, about how it's a bad idea to be storing secrets on a phone, because you cannot count on there being a layer of encryption protecting it. And even if you could execute code on the device while you're using it, for example, by tricking you into installing a malicious app, which happens all the time, then that encryption does nothing. Once you've logged in, everything is decrypted. The only time encryption protects the phone is if someone steals it when you're not logged in. Android phones update for about a year, then they don't. Yeah, and it depends on the brand. So, I mean, I think if you get higher end phones, it's better. But they really don't have an efficient update channel, especially for the old ones. And That's really bad. That's why if you pay attention, Microsoft Windows has gotten pushier and pushier about forcing you to update, because they've increasingly figured out that old versions are really terrible because an exploit comes out. And so, but Android hasn't really gotten there. Anyway, so let's take a look at a Kahoot. Let me go back to my browser. I'm very pleased at how well everything is working today. And I've done many things to my computer, but I got the Kahoot, I got the Zoom working, but I broke the Genymotion, so you can't have everything. Anyway, so we're at 128, and it is 6B. 6B sounds right. Yeah, 6B is right. Okay, good. We're at 31. All right, probably a few more coming. Let me get my page to put the answers on. Okay. Well, it's like they've changed their music options. Give it a few more seconds. All right. Give it 5 more seconds. Guess that's it. All right. What does an app signature prove? It doesn't prove any of these. It doesn't tell you who the developer is. It doesn't mean it came from, this would be nice if it proved any of that. It proves nothing. We are going to sign apps. We are going to take apps that other people wrote, modify them, and re-sign them. And the Android operating system will accept that signature as sufficient to install an app. That is sort of mind-blowing. This signature does not prove what an SSL certificate proves at all. All right, what vulnerability used 2 files with the same file name in an APK? Okay, that's called the master key vulnerability. All right, what file lists the permissions that an app has? That's the Android manifest. Good. All right. And what permission level should an app use for a new permission? All right, what's recommended is signature. So nobody but you, apps from your company will ever use it. That way you control what might happen with that permission. All right. I know who that is. I don't know who that is. That looks like a real name. All right, good. So I'm going to get rid of this. And I'll stop the recording.